Okay, hello everyone. I hope you are able to see and hear me out there. It seems like there's quite a few people online, which is great. Keep the chat alive and talk to each other. Welcome to another quarantine live stream. Here we are, we're still in quarantine. That's the whole deal with quarantine, I guess. It lasts for a while. It's day 5 of my quarantine, and outside in the society, it's all a bit shit, I guess, right now. But let's give each other and ourselves the gift of just for a while coding SuperCollider and ignoring the news. And you can go ahead and you can unplug your fax machine, ignore your fax machine. It's all good because right now, just for a while, we're gonna work with SuperCollider and make a bit of music and have a bit of fun, hopefully. So I'm still here. I'm still in my makeshift recording studio, which is still literally an ironing board, and I've still got my terribly loud gaming keyboard here. Harsh noise gaming keyboard, and I'm still doing pretty good myself in spite of it all, and I hope you're doing pretty good as well. Just a heads up before I start, the last couple of streams have ended very abruptly due to technical errors that I simply have not been able to figure out. So this time I've tried to tweak some settings and hopefully it's a bit better, but let's just assume that this stream is going to end at some unfortunate point in time, and I'm just gonna hurry up and start the show for today as fast as possible. But just so you know, if the whole stream cuts off, then you know that's the end of it. Then the higher powers that be have decided that we shouldn't be streaming anymore, and I honestly don't know what's going on. I've tried to figure out what the error is, and I haven't been able to. So let's just go with the flow and see how far we get. Fortunately, the last couple of times we've been able to end in good time, and hopefully we will today as well. As with the other live streams I've done, this one is just completely off the cuff. It's improvised, and I don't really have any pedagogical material guiding me throughout it, except for my very dubious experience with SuperCollider and my gut feeling. So bear with me if it gets a bit chaotic. This isn't a theory class. This isn't I don't know, a textbook class. We're just gonna mess around a bit and see if we can learn a bit or have a bit of fun at least. So for today, I thought that it could be fun to just try something very, let's say, conventional. And that is, let's say the goal for today is that we want to do two things and make those two things work in tandem. So the first thing we want to do is we want to write a SynthDef. So that is a definition of a synthesizer, and I'll get back to that in a minute. And once we've written that SynthDef, we want to use it and control it using a pattern. So we're going to both touch on synths and we're going to touch on patterns. It's not going to be a terrible amount of theory here. You can read that in the help files or in some of the many good books available out there. In the description for this video, you will see a link to something called the Awesome SuperCollider, which is a list of really good resources. So if you want a proper introduction to either of those, then go ahead and find them in there. But that said, I'm gonna dive straight into it because what we want to do at first is write a SynthDef. And I've had a few questions actually from people after doing these videos, and they've asked me what the setup is for my code editor here, and it's simply NeoVim with a plugin called SCNVim, and there's a link for it as well in the description of the video if you're curious about that. So we're going to go ahead and make a synth definition. So the idea for this synth is that it's going to be a kind of synth that we will play once, like one note, and it's gonna make one sound for one note, and then it's gonna kill itself and disappear. And then the next time we need to play a note, it's gonna spawn a new synth, and that synth is gonna play a note, and then it's gonna disappear as well. So that's kind of the design mentality behind this, and this is a very popular strategy for working with this kind of thing in SuperCollider. It's not the only strategy. You can do this kind of thing where you spawn a synth and then you tweak it, but we're not going to do that today. So here I am. I have a SynthDef.new. I'm going to give it a name. I'm going to call it mess, because that's my name. And I'm gonna say comma and then add a function here. And then after the last parentheses, I'm gonna say add. So this add adds the whole synthesizer as a definition to the sound server. So the sound server is able to use this as a sort of recipe for a sound. So that's the goal. We're gonna fill this up with a bit of sound. We're gonna keep it simple. First, I want to add some arguments. I'm gonna use, there's two different ways you can write arguments. You can either write arg and then la la la, la la la, and then add a comma. Oh. But I prefer this way. So it's two pipes. No, these aren't L's or anything like that. They're pipes. And the things we want as parameters for this synthesizer are frequency, and we're gonna set a default value of 444. That's hertz, of course, and we want a amplitude. The default value, let's set it at 0.25. We want a panning value, let's set it at 1. And then we want a duration. Let's set that to 1 as well as a default. So those are our parameters. We're gonna stick them in here and we're gonna use them in our little synth. The synth is gonna consist of an oscillator, which we are going to put into a variable called sig. And we're gonna control it, the amplitude of it and the curve of it, using an envelope that we're gonna stick in a variable called env. So these are the two variables that we are going to work with here. So first of all, let's take sig and then put something in here. I have a tendency to always use sine wave oscillators, and so today I thought, why not use a sine wave oscillator today? So instead, let's try a triangle oscillator. So triangle wave is kind of let's say it's the closest sibling to the sine wave in terms of waveforms. It's got a bit more of harmonics than the sine wave, because the sine wave doesn't really have any harmonics if it's a clean one. So it can be a bit more, well, to be honest, this is going to sound a bit like a Game Boy, I think. So let's just be honest with each other here. So we're going to add in the frequency as a parameter, the frequency that we put in above here. We're gonna use that directly in our triangle oscillator, and so that's now playing. Well, it's not playing now, but in our imagination, it's playing a sound. So we want to, at the end of our synth, we want to say out.ar to get the output, and then oh, I forgot to define that upstairs, but upstairs? Yeah, that's actually a good word for the place you put the parameters. Let's call it upstairs from now on. And I forgot to put a parameter upstairs, which is the parameter for the output. And that's simply the output bus channel, or the output channel, you could say. And then the second argument is the signal that we're working on. So it's not done yet, because if we just play it like this, it's going to spawn the synth and not end, because it doesn't really handle the duration yet. It doesn't really have a way to figure out when is this note done playing. So that's actually one of the two things that we're going to use the envelope for. So the envelope is going to tell the synthesizer when a note is done, and that's when it's progressed through the envelope. So let's make an envelope. An envelope consists of env generator, and inside of the env generator we're going to put an actual envelope. I like to use, you can either define an envelope, or you can use one of the methods that come with env. the env class, which is the envelope class. I like to use this perk envelope. There's a few different ones. You can look up the help file for env, and you can see some of the built-in ones. I like perk. It's a percussive synth. It's a percussive envelope, so it's useful for a lot of things like this. And we're gonna give it an attack, a release, and the level, which is going to be 1. That's the amplitude. Well, actually, let's just keep it at those two, attack and release. Okay, so that's the env inside of the envelope generator, but that's not all we need to do here. We need to put in a gate. Let's set it at 1, so that every time this synth is spawned, it's got a gate of 1. That makes sense. Let's ignore this, and then use this time scale. So the time scale will scale the duration of the whole envelope. So now the duration of this envelope is 1, because that's the, well, that's gonna be the default value anyway in a minute, because we're gonna set the attack at 0.1, for example, and the release at 0.9, and that's gonna total to 1. So if we scale the duration of those, we can do that here, which will scale the whole duration of the whole envelope, and we're gonna use this duration parameter that we set up here. And let me just go ahead and add an attack and a release. So these are attack time, oops. This is the attack time and the release time. Okay, so we have an envelope generator. It contains a percussive envelope with an attack and a release. It's got a gate, which is simply just on, and then it's got a duration. And the last thing we need to do here, and that's one of the more cryptic things if you come from another programming language or another synthesis environment, is this done action thing. And it seems very cryptic, but what it really does is that it informs the synthesizer of something when this envelope generator is done doing its thing. So that is when it's had its attack and it's had its release, and when it's done playing. So the sound goes up and then it goes down, and then what's supposed to happen after that? So what's supposed to happen after that? Well, what I said in the beginning was that we want to have this synth just disappear and die. So that's 2. That's done action number 2. So unless you want to do something else, then quite often it's done action number 2 that you need for a thing like this. So just make that a habit. So unless you need to, otherwise, then use done action 2, because done action 2 will free the whole synthesizer once it's done playing this envelope. And so right now we're not using the envelope for anything apart from killing the synthesizer, but we need to use it to control the amplitude of the signal. So that's quite easy. Since we have signal inside of this envelope called sig, we can say sig equals sig times env. So this will apply the envelope because it's gonna multiply it. And we then also need to use our amplitude parameter, which we call amp, to scale the whole thing. So the envelope is going to go from 0 to 1 and then down again, and the amplitude is going to make sure that it's scaled to a higher or lower level of that, depending on your need. Usually you need it lower than that because things can get quite loud. So I think actually that this is all we need. Let me just add a comment here. Envelope does 2 things. It controls the duration / lifetime of the synth and the amplitude curve of the synth note. I'm not sure if that's a good explanation. Scale signal by envelope. Volume control. Spit out the signal. All right. So we now have a synth, and let's see if we can evaluate this. We can't because I forgot this. So it says variable out not defined in interpreted text. So that's a quite simple error because I used out here, but I haven't really told SuperCollider what out is. I haven't defined it as a variable, and then it just assumes that it's supposed to be a variable, but that hasn't been defined yet. But instead, it's actually a parameter upstairs. So I'm going to add it here and set it to 0, which is the default value. And now it runs. It says a SynthDef, which is a good sign. So we now have a SynthDef, and it's added to the server, but we just need to make sure that it actually works